Hello and welcome to Chemspec Digital 2021. My name is Imran Omar, and I have the pleasure to introduce the first presentation in this conference stream. But before I do, please note that we are recording this presentation to make it available to view on demand. Attendees are invited to write questions to the chat function from where we will read them out at the end. For now, I will hand over to Hans Kiswetter of Netsch 5-Mile Technique, who will be presenting plants solutions for most efficiency, sustainability, and environmental compatibility in agrochemicals. Over to you, Hans.
Thank you, Imran. And hello, good morning also from my side. Imran already introduced the topic for this presentation. This is a very actual topic, and especially sustainability. How is it in conflict with efficiency and environmental compatibility? This is what I will point out in this presentation and showing you solutions, how it can be solved in the production processes for agrochemicals. My person, you see, I'm working in a company Netsch since 2002, so it's almost over 19 years. Was passing different departments, and since 6 years I'm a global manager, business field agrochemicals. The company Netsch is divided in 3 business units. On the top, there's a holding, and I am from business unit grinding and dispersing. But you will find also pumps and other systems that we implement in our process lines and that we use for equipment. Not analyzing testing, this is a completely different issue. So we will talk today mainly about grinding and dispersing. Yeah, the company Netsch 5-Mile Technique has then several business units. As you can see here, we have a chemical business unit, food and confectionery. We have pharmaceutical business unit and minerals and mining. Brand new is that also service after sales is a special business unit, so that we concentrate also in after sales with solutions on the market and on our customers. Our company is worldwide located, as you see here. We have worldwide production facilities. We have a worldwide sales organization. In the production facilities, we have also laboratories where we carrying out tests with products of our customers, demonstrating the equipment in lab scale and doing them scale up to production scale. We have also worldwide a service network where we're providing service from regional locations, from region to region. So we have a really complex network, and all this together we are communicating in the head. Headquarter is Netsch 5-Mile Technique in Selb in Germany. It's in the northeast of Bavaria. Very close to the Czech border, just to give you an impression where the origins of company Netsch are from. Yeah, the company Netsch, as was mentioned in the topic, sustainability is also a big point for Netsch. We are active in our daily work. We have activities that also how to say, Netsch gets the green button, and that's why we are also registered, especially here in EcoVadis. This platform where we are presenting and demonstrating our activities and what we are doing for sustainability. This is a rating platform, so you can see here how we are positioned, how we are doing. therefore, we have to not only to be registered to how to say to make okay behind. We have to think about what is sustainability. What is it for us, for ourselves internally, but when we are provider of service, of equipment, of complete process lines, what we are designing, we have to think about what is sustainability for our customers. And here you see an overview what's around sustainability. Though there's a social area, as you can see here, that includes humans and society. So this is describes the conscious organization of social and cultural systems. There's an economical part, including technology and availability. And this describes maximization of economic yield. Yeah, what is very important, especially for the customer or for the producer, as well for ourselves. Economical, this means to make profit somehow and to be profitable. Then the third field is the ecological field. This cares about raw materials, about the nature. This describes the far-sighted and conservative use of natural resources. All this is together is sustainability, the definition. And what we have to keep in mind is that there are some interactions in between, fair growth between social and economical, fair use between ecological and social. This is more internal for your own purpose. And this is what we are keeping in mind and having in focus, that between the economical and the ecological from history, there's a constant profitability topic, and this is quite often the problem in sustainability. This shows the next slide. Sustainability is from history in production processes always in conflict or with economic efficiency and environmental capability, as you remember from the topic of my presentation. So in this conflict, this needs to be solved, and this is the task for the future. Means that we have for you find to do measures to increase the efficiency by improving or at least heating environmental capability, so that this conflict will be solved between efficiency and environmental capability. And the solution for this, as you can see here, is innovation. This is the big point for us, and this is our philosophy, that doing innovations regularly to optimize your products, to optimize the technology, the processes, systems, products, etc. And if you are successful here and you have here good solutions, to optimize the technology and processes, then you're back in the field of sustainability. Then you have a process, you have a solution that allows you to say, okay, I am not in conflict anymore with this points of efficiency and environmental capability. So this means for us, we have to understand our customers. What do they need? The customers, they are looking for, as already mentioned, profitability, highest productivity, high quality. In agrochemical, it's very important that there is equipment and processes that easy to clean with lowest cleaning amount. The producers, they are looking for highest operation safety, not have to have equipment that every time or quite often stops and have to be maintained or or repaired. Also dust emission and emission-free process design. This is very, very important for environment, yeah, and because there are regulations from government, from government institutions that have to be followed up by customers, and he has to fulfill. And we have to think about it. And we have to keep in mind in our solutions that we are fulfilling all these needs of the customers that you are seeing here. So as well as already mentioned, service digitalization is a brand new topic actually in society, and especially for agrochemical processes, temperature control, because the active materials in plant protectives, they are temperature sensitive and there are temperature limits, and this is the worst case. If you design processes which do not keep the temperature, then the very expensive actives will be destroyed. So all this, yeah, we have in mind, and this is important for us, and this is our philosophy, thinking like the customer. And then with these points, with these topics, with this task, yeah, to work out measures and then to do innovations, and at the end to optimize and have solutions for optimized processes. So this means as well we need to be aware about where we are active. We have to know what are fertilizers, what are plant protectives, what is seed treatment. So we are familiar in this product fields. We know the specifics. We know about the needs, about constellations. So what is important? We are present in different associations, so that we are full aware about all the background and all around of this application fields. But not the only the global applications, but in detail that now we coming closer to the process solutions, process design. We know about different product types. There are solids, there are liquids, and there are different products that finally are produced. We are not doing all products. You see the red ones here. There we are specialized, and for these products, for these different products, we have also designed our equipment. We have special design. We have adapted to the needs to these different product types. And this is then what we see here, that we have a matrix. We have plenty of different machines for the different applications to use in mixing and emulsifying. So mixing systems, inline mixers, stationary mixers. We have equipment for pre-grinding, supporting the pre-mix process, especially adapted to these needs of these categories here. And we have then equipment for wet grinding, so that to the mill base before then finalizing the product finally in the complete process line. And yeah, this process line, typical process line you see here, standard process. There is a mixing stage. There are the raw materials are fed in and mixed and homogenized. Then it goes in the next process stage that we call milling stage. Intermediate tank is collecting the material, and then it's passing the mills. And at the end, we have a storage tank. And this is the typical process line for a SC formulation. And for such processes, as already mentioned, we have the know-how of the equipment, how to design the equipment, how to run the equipment, how to optimize the design, how to optimize process parameters to use it in the best way. keeping in mind the sustainability and what is our customers know-how. You see here, he knows the materials, definitely he knows the formulation, he knows about critical parameters, and finally he's defining the product quality. And all this has to play together. So we are communicating. We are asking customer as well as he's asking us about the technology and features of our technology. We are asking the customer about his needs in the product quality, about his fears or worst cases that could happen regarding formulation, about special behavior of the raw materials. And all this together is important. This is defining our task to analyze all this information and then to work out best solutions, and ideally to have some innovation that allows to optimize your process. Yeah, and after all this, we have, sorry, this was too fast. We have here, as example, a complete layout of a SC production line, which is split in the formulation line. Our how to say, actual technological standard for formulation line, and there's also then the line for the thickeners, and at the end both are mixed together. It's then finalized in the letdown unit, in the letdown process step, that at the end customer has his final product, what he's selling then to the farmers. Here you see that we are not building all equipment ourselves. We have the dark green fields, that is our score equipment, our own equipment that we are producing ourselves in our different production facilities worldwide. And for the light green ones here, we have very good suppliers that we are contacting for the individual projects individually, and with the special requirements for individual products. So, and all together we are supplying that then to our customers as a complete full process line, even as a turnkey plant in the best way. So, and to get to this result here, to such optimized and how to say, highest technology standard solution. I already mentioned there needs to be done some effort to think about to find solutions for current processes, to optimize them, and as already mentioned, mostly such solutions are realized by some innovation. And we have, regarding the current process lines, which is typical old existing technology in the market, we were watching the different process steps, the mixing and the milling process step. And here then we were doing some innovations. First, for sure, the mixing process step. So we were thinking about to replace the existing standard mixer by our inline Psymix, which ensures higher productivity, better cleaning, higher operation safety, better product quality. And to show how it works, yeah, that finally the complete process will working properly with our new process step in the mixing technology. Yeah, I will show you what is the innovation. So the old technology was simply to disperse a powder into the liquid, and this is quite complicated. You have to move a big volume with the drive, with the shaft, and when powder is falling in, it's getting first sticky. So this we have analyzed the problems, and we said, does it not make sense if we have powder that first we are trying to atomize the powder in the dry stage, and then to let fall the single particles in a very thin liquid layer that we have maximum of surface wetted, and then we are collecting this. And ideally, this all happens under vacuum, because vacuum means that also the capillars inside, they are free of air. And when this happens all in a machine and we come back into atmosphere condition, the atmospheric pressure, the hydrostatic pressure will push the liquid into the center of the capillars. And this was the idea, which was designed on a small paper. And yeah, this is what happens, as already mentioned. We have here problems in the existing process, and we are looking for physical principles to find solutions, new solutions, to have at least no dry course anymore in the product. Here in these old processes, as just the surfaces are coated and then cut it and again coated the surface, the center is always dry. And with this new idea and with these new principles, we can enter, in this case, what's theoretical thinking, we can enter to wet all specific surface. So now our task was to bring the idea from the paper into real technical hardware. And here you see that we designed a machine that is collecting the powder, is atomizing the powder, like here. Then it's diving in the powder in a thin liquid layer, what's happening here. And finally, the wetted powder is going out into atmospheric stage, what it's doing here. So we found a technical solution that ensures at the end that we have no dry course, we have micronized powders, we have dispersed product, and no dry course anymore in the center. And this innovation, this leads that yeah, we have better quality in the premix. Yeah, the quality of the premix is much better. And as I usually say, the better you bite in something, the less your stomach have to do. And this is quite logical also in production processes. The better the premix, the easier, the faster, the less intensive the milling process has to be then afterwards. What I have to tell here, maybe you think, oh, I know this design, it's a rotor starter. It isn't, as we have not the narrow gaps between rotor and housing like in a typical rotor starter. So, and this is yeah, leading us that yeah, with this technology, what you see here then in hardware, that the process design is then finally like this. We have here this core technical part of the machine on a frame with a drive, and the principle is that we are circulating, and it's designed for full process lines, automatic processes, for big scale processes. This is very good, the best solution we have on the market, I would say. And yeah, to underline the benefit of this principle, you see here comparison in more detail, comparing the power wise batch size, and it's logical. When you have a batch mixer, the bigger the batch, the bigger the volume, the more power you need. the Psymix, when you remember the layout, you have the machine circulating with a batch tank. So the mixer is always the same size. It's a unique size, and then you can connect with different batch sizes. So you're very flexible, and always you have a low power consumption. And also specific energy-wise viscosity is very interesting to have a look on. You see with the standard mixer, high-speed mixer, the higher the viscosity becomes, the more power you need. It's logical. You have to move the product and you have to spend energy. The Psymix here is less sensitive and is working more effective, like a standard mixer. So next thing is also when watching this technology, you see we have here a very small process chamber of 4 liters compared to a big tank of 5 cubic meters, for example, where the powder is added. You have on the top then a surface that can be coated by dust, and this has to be cleaned. So it's almost 1/5 of the total volume. You need clean intensively because powder is sticking on, yeah. And here we have just 4 liters, yeah, 4 liters process chamber, which can be easily cleaned with lowest amount of cleaning agents and cleaning liquid. And the tank, which is here in circulation, just there's no powders, it's a slurry, and it just can be flushed out with fewest amount of liquid. We say that here per 1,000 liters, we need approx 50 to 100 liters cleaning agent to clean it really very good. And as mentioned, with this technology, we need in total 1/10 of standard mixing technology. So this is a very big benefit for the customer, reducing cleaning amount and making it easier to clean. And even cooling is very important, because cooling means spending energy. With this small process area, and as the Psymix isn't a rotor starter, we are not heating up the product. But nevertheless, we are recommending here the cooling on this circulation tank to have for the rest of the process constant low process temperature of the product. And last but not least, as I mentioned in this theoretical sketch, we were looking for a unit that's working under vacuum. So after the powder is in the circulation mode, then we close the valve, and then we are running a homogenizing mode and using the physical principle of a water jet vacuum pump, and that it's then leading that the micronized air is getting out, and we have really after this mode homogeneous quality, much better quality compared to standard mixing technology. This is very important because the customer wants to sell product and not to sell air in the bottles or canisters. And here, to underline the benefit of this Psymix compared to a standard mixer is, this is very strange in the first case, because you see here that the quality after a mixer is at least not differing from the Psymix. But as I mentioned, we have soft powders, we have fully wetted out, even the core of the particles. That do we not see in the particle size here, but in the later milling process, we see that here we will see the advantage that the milling is easier and we get better quality than in the following milling stage. And this is the big point, that we optimize here the quality of the product. So the next step, optimization, we did. This we did already. Now we said, okay, we will replace the rotor starter, which is usually in the process, by our Profi. It's a agitator bead mill type, which has much better features compared to rotor starter or coid mill system. So the Profi, as mentioned, is a agitated bead mill. So we are using all the features of beads, grinding beads that are doing the job by friction or impact forces. The beads are in this mill chosen quite big so that we can break the coarse particles and do an efficient job here. Yeah, how is it looking like, this process? This Profi pre-mill is between our Zymex and the circulation tank. And so the Zymex, the powder goes in and then directly through the mill, and then it's circulating in this loop by a very high throughput compared to standard mill in a mill stage process. You see, we are doing very, very high throughputs to this Profi pre-mill. And the results, we were comparing mixer with colloid mill, mixer rotor starter on the Profi, is that in time we could optimize the process, the specific energy input we could optimize, and even the quality after this pre-dispersing stage was much better compared to standard process solution. So we have solution, we have optimized with our solution the premix. Yeah? The Profi, we have different sizes that you see here, 10, 20, 60 for different batch sizes. We can do scale up from one to the other one. Yeah, this is what we are offering, what we have so far in our program. So, and a third step, yeah, we already optimized the premix, the support of the premix. And now we are going to milling stage, because this process, which is typical for fungicides, insecticides, such cascade process of mills, we have 2 mills, and we say, okay, that's quite a lot. Can we save 1 mill? Can we cancel 1 mill so that at the end we have this process here, which is compared to the very original process to the current process. You see the different optimizations there, and it's a reduction of machines finally. So we have less equipment, less to clean, and we have, yeah, coming with better quality, and we have innovative technology here in this process solution. So how we can do it? So this is the story of our optimizations and innovations we did with our discus mills. From history, since many years, we are always looking to optimize, to develop further our mills. In the heart of the mill is the rotor and the separator of the mill. The rotor is activating the beads are doing the job with impact and friction forces, reducing the particles. The separator, what we see here, has the job that only product goes out and no product will, no beads will be in front of the gaps of the sieve cartridge. And this goes together, the activation systems with the disc, and this activation separation system with the classifying rotor. This continuous developments allow also to think about process optimization and as already mentioned, reducing scope of equipment. Here you see in 2014 the patent for DCC expired. So from this time on, we could see also in other brands, other producers, this technology, but we are one step ahead. We developed further. And what is the benefit? What you see with this development is that the grinding disc design, what we changed from a triangle design to a square design, Tetranex. The rotor classifier, as already mentioned, we have a DCC before the patent expired. Now we have an intensive ICC. The spacers we optimized, and also the grinding chamber material, from steel to ceramic inner liner, we optimized the machine. This allowed that we can spend more energy into one machine. And here you see that from originally 80 kilograms in two-pass process, finally we can do now with the newest art of technology 400 kgs in one pass and keeping the temperature. This is very important. And all these features together, all these innovations and optimizations of the mill leads that we can think about changing something in the process. Here you see our scope of these machines, very interesting. So we have from lab to production scale, we have scale up factors, so we have full program for every application. And now here, this is very interesting now that we do the comparison. We look what is efficient and what is effective, and always keeping in mind sustainability, all the features with the innovations we did with regard to sustainability. So we had originally, we had a process 6,000 liter mixer, a rotor stator, and then a two cascade mill stage with big beads in the first mill, smaller beads in the second mill. This process was doing originally 1,000 kgs for a requested fineness of D90, smaller 7 microns. With all the changes I explained to you in the slides before, you remember we installed the Psymix instead of the mixer, and we did instead of a competition old mill, we did in the first stage install 2 of our discus mill with the old DCC separator. You remember the patent expired a few years ago, and here we could increase the capacity significantly to the origin process of a customer. So with this installation, he could at least, with a number of equipments, with number of hardware, increase his productivity. But we have some special innovation. It's our new development, the Profi. With this new process design in the pre-mixing stage, in the pre-dispersion, you remember we could reduce time of premix, specific energy input, and also the quality, the fineness. We could reduce from 60 to 30 microns, and it's logical. When I have better quality, I can optimize then the following process. So the consideration was, why to run any more 2 mills? Let's try it with 1 mill of same size with a new separator system, with this ICC design. And it really, we succeeded and had success here. We could even increase the capacity with this new process solution. So optimized inline premix stage and 1 mill in the milling stage. And regarding specific energy input, all in all, in the total, when we are comparing, you see that with a standard process, with a mixer, you get a certain quality far away from requested final quality, and so the mills have to do a big job, and therefore you need more mills. With our new, better premix solution, with this innovation, we could optimize the premix quality, and so the final step to final quality is very small, and that can be done with one unit. So the specific energy reductions is very, very impressive what we can realize with our new innovations, what we are implementing in the processes. And here you can see an example for fertilizer, as we are not only focused on plant protectives. You remember the slide, fertilizer, plant protective, seed treatment. We are active. Here's a typical standard process for fertilizer. Again, a mixer, rotostator, again, cascade process. And here you see some numbers of this process. So the process is lasting very long. the premix, the pre-mill in total, very long. The installed power is very high. You have a lot of equipment. You need a lot of power for each single equipment, so that at the end, specific energy input is also very high. By all our optimizations with the premix stage and with the Profi, Bimix Profi, and the new middle design, you see the difference that we can finally, comparing this process, finally save time and also specific energy to have at the end at least same product quality. So this is very impressive numbers. And yeah, coming to the end slowly of my presentation, you see that, as already mentioned, we do also turnkey plants. And our special feature, our specialty is that we are doing modular turnkey plants. It's like a puzzle that we are designing each process step on the module, and then we fit this module together, and then we just do the connections on for the main medias, and there you can install within shorter time a complete plant. Interesting from last project, it was also that there was problems in delivery due to customs problems, and then storage was requested, and such modules are also easier to storage. Or the first plant we built, the idea of the customer was to install and reinstall and move the plant to another location. So this is possible with such modular systems. Okay, it's quite difficult because these are nine modules. It's quite big. With a smaller plant design for smaller production capacity is something to think about. Yeah, and then it's quite sustainable. Yeah, if you have one plant, you can use on different locations, or you have on each location to install a new plant, an individual plant. With these solutions in small scale, this plug and play and replug and reproduce ideas is very very common. Yeah. Finally, our service activities are that what we are also focusing on, after sales service to ensure that the plant will run is very important. Digitalization, we are aware we are doing, especially for plant systems, so that we coming finally, you remember this slide with the customer needs. Now we can talk about solutions, what we found, what we did for all these single points. You can remember, and you can see we found solution, and at the end of the day, yeah, we did really by innovations, we did optimize the processes, and at the end of the day, our customers, they really benefit from our activities. That's it, our activities and our work and our job to give or to supply sustainable solutions. I think we are on a good way, and we will for future for sure continue this way as a service for our customer. Thank you very much.
Thank you for the presentation, Hans. We're now in a question and answer section and taking any questions that you may have. Let's wait for a few minutes and see if there's any questions coming in. Yeah, at the moment, I mean, we haven't got any questions, so you probably, yeah, you understand your presentation very well, Hans.
Okay, that's good. Anyway, I think all participants have contact, and they can afterwards, the next days, also contact me directly if they are more interested in one or other detail.
Sure.
We can individually explain. So,
okay. Well, I mean, we haven't got any questions, so I guess this marks to the end of this session. Thank you very much, Hans, for presenting, and also to our viewers, feel free to reach out to Nat on the platform afterwards. Thank you for watching, and goodbye.